Comptia Network Plus course, Installing a Wireless Network 4174. From here you can set the device to run BG, only G, or even mixed mode, which happens to be the default. You can also change the SSID from Linksys to another name, and I highly recommend doing so. The AP channel can also be changed, and you can turn off the AP beacons as well, which is also recommended. But understand that if you do this, you'll have to set the new SSID name in each of your clients. Last thing, you can see that by default there's no encryption. Click the wireless security tab and you'll get this screen. From the pull down menu, you get to choose from various wireless security options if you want to. Site survey. I want to be sure you're completely clear about where I stand regarding site surveys. They are absolutely and vitally imperative to bringing a premium quality, even just a reasonably viable wireless LAN into this world. You should carry out a pre-deployment survey and post-deployment survey, but keep in mind that your pre-deployment survey isn't actually your first step to begin this key process. So because you must know how to formulate and implement a solid site survey, I'm going to walk you through executing the 3 major steps in doing that effectively. And just to be really thorough, I'm also going to cover some issues commonly encountered as you progress through these steps. Information gathering. This is actually your first step, and during this stage you must determine 3 key factors. The scope of the network, including all applications that will be used, data types that will be present, and how sensitive these data types are to delay. The areas that must be covered and the expected capacity at each location. The types of wireless devices that will be used to be supported, such as for example laptops, iPad, iPhone, IP phones and barcode readers. During this time, a key goal of mine would be to create a coverage model that maps to all areas that need coverage, along with those that don't, and have my clients sign off in agreement to this document before I do anything else. You definitely want to do this. Pre-deployment site survey. In this phase, I use live APs to verify the optimal distances between their respective locations. I base this placement on the expected speed at the edge of a cell, the anticipated number of devices, and the other information gathered in step 1. Usually after I get an AP positioned, I'll place the next one based on the distance from the left, with special consideration given to any sources of interference I found. Post-deployment site survey. I utilize the post-deployment survey phase to confirm and verify that the original design and placements are happily humming along problem-free when all stations are using the network. This pretty much never happens, so at this point it's likely changes will need to be made, sometimes significant ones, in order to optimize the performance of a wireless LAN operating under full capacity. Providing capacity. Now here's a big issue that frequently rears its ugly head: providing enough capacity in areas where many wireless stations will be competing for the airwaves. Remember that stations share access to the RF environment with all other stations in the BSS as well as the AP. So really the only way to increase capacity is by increasing the number of APs in an area requiring serious density. This can get complicated, but basically it comes down to placing APs in non-overlapping channels while still sharing the same SSID. Take a look at figure 12, 1217 for an example of this scenario. In figure 1217 there are 9 APs that have been configured in the same area using 3 non-overlapping channels in the 2.4 GHz, 1, 6 and 11. Each shade represents a different channel, even though the AP on the same channel has been positioned far enough away from the others so that they don't overlap much and or cause interference. Surprisingly, it's actually better if there is some overlap, but bear in mind that the channels should be used in that way that no APs on the same channel overlap in a detrimental way. Another thing I want to point out that's not so ideal about this arrangement is that all the APs would have to run at full power. This isn't a good way to go because it doesn't give you much fault tolerance at all. So we've got two problems with our design: lack of overlap and lack of fault tolerance. To address both issues, you need more access points using 802.11a, b and g, which would get you more channels and provide better throughput as shown in figure 1218. Multiple floors. Another special challenge is a multi-story building where wireless LANs are located on all floors. In these conditions, you've got to think about channel usage in a 3-dimensional way, and you'll have to play nicely with other WLANs administrators to make this work. Facing this scenario, your channel spacing should be deployed as shown in figure 1219. To prevent bleed from one floor to another, use semi-directional or patch antennas to control radiation patterns. Location-based wireless LAN. When using a location device such as the Cisco 2710, your restrictions get even tighter. The additional requirements for the location device to operate properly are as follows. APs should be placed at the edge even when they are not needed. They are for normal coverage purposes so that devices at the edge can be located. The density of APs must be higher. Each AP should be 50 to 70 feet apart, much closer than this normally required. Some APs will need to be set in monitor and scanner mode so that they won't transmit and interfere with other APs. All of this means that the final placement will be denser and a bit more symmetrical than usual. Site survey tools. As I've touched upon at the beginning of our site survey section, there are some highly specialized, very cool site survey tools that can majorly help you achieve your goals. The Air Magnet Survey and the Akahu site survey tools make it possible to do a client walkthrough with the unit running, and you can click each location on the map. These tools will gather RSSI and SNR from each AP in the range, and at the end of your tour, global heat map coverage will be magically displayed as shown in figure 1220. Wireless security. So wireless security is basically non-existent on access points and clients. The original 802.11 committee just didn't imagine that wireless hotspots would one day outnumber bounded media hosts, but that's actually where we've headed now. Also, unfortunately, just as with IP version 4 routing protocol, engineers and scientists didn't include security standards that are robust enough to work in a corporate environment, so we're left with proprietary solution add-ons to aid us in our quest to create a secure wireless network. And no, I'm not sitting here bashing the Standards Committee, because the security problems we're experiencing were also created by the US government because of export issues with its own security standards. Our world is a complicated place, so it follows that our own security solutions would have to be as well. Wireless threats. Protection of data and the authentication process are certainly key threats, but there are other wireless security pearls lurking out there as well. We'll delve deeper into the process and procedures designed to mitigate these dangers in Chapter 14, but I want to briefly discuss them here. Rogue APs. First, there's the evil we call rogue APs. These are APs that have been connected to your wired network infrastructure without your knowledge. The rogue may have been placed there by a determined hacker who snuck into your facility and put it in an out of the way location, and more innocently by an employee who just wants wireless access and doesn't just get how dangerous doing this is. Either way, it's just like placing an open Ethernet port out in the parking lot with a sign that says corporate LAN access here, no password required. Clearly the worst type of rogue AP is the one some hacker has cleverly slipped into your network. It's particularly nasty because the bad guy probably didn't do it simply to gain access to your network. Nope, the hacker likely did it to entice your wireless clients to disastrously associate with the rogue AP instead. This ugly trick is achieved by placing the AP on a different channel from your legitimate APs, and then one's setting its SSID in accordance with your SSID. Wireless clients identify the network by SSID and not the MAC address of the AP or the IP address of the AP. So jamming the channel that your AP is on will cause your stations to roam to the bad guy's AP instead. With the proper DHCP software installed on the AP, the hacker can issue the client an address, and once that's been done, the bad guy has basically kidnapped your client over to their network and can freely perform peer-to-peer attack. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.